first. Okay, if you're joining this virtually, as I know Virgie is today, then I've just started the recording. We did our welcome and we're going to get started on the content. So, we're talking today about correlations. This is chapter 11, so you can see we're taking a jump here. And we're going to talk about correlations. So let's get that right down on the top of our screen. Correlations. And correlations are just about relationships between variables. So let's imagine that I was interested in knowing whether your quiz scores have anything to do with your exam score, if they have anything to do with each other. So what would you be likely to think? Like if I gathered your quiz scores for every one of you, and then I gathered your exam scores, would you expect that, like, what would you expect if quiz scores were increasing as quiz scores got higher? Would you expect that, like, in general, people with higher quiz scores would be likely to have lower exam scores or higher exam scores, or that quiz scores would have absolutely nothing to do with exam scores? So I'd like you to either speak with your voice or put something in chat that says whether you think there would be any relationship between quiz scores and exam scores. Okay. So I see one response. Let me just ask a couple of you to speak on that. Colin, what do you think would happen as exam scores got higher? Like if I looked at, as quiz scores got higher, what do you think would happen to exam scores? Would they get higher?
Yeah, they would get higher.
Yeah, they'd probably get higher, right? So we kind of predict that there's some sort of a relationship that if we looked at the data. So that's what we're looking at. Now we can't use correlations to say, so I'm going to let me draw a red arrow here. We can't use correlations to compare two variables. If we're comparing two variables, if we're comparing or a variable between two groups, then we'd be looking at like a t-test or something like that. And we can't use correlations. So this is a not. And we can't use correlations to determine whether one thing causes another. A causes B. So we can only use it then to look for a relationship to see if they have anything to do with each other. And typically for correlations, we use continuous variables. And so let's just review that idea for a moment before we get started. And so continuous variables are variables that we can do it with ordinal variables. And we can do it with continuous variables, but they have numbers on a range in sequence. Let's just put it that way, on a range that covers both ordinal and continuous in sequence. And so they are not nominal or variables that indicate categories. So just take a few examples of these, and then I'm going to ask you for some examples. So when we think about nominal, we might think of like eye color. If we listed the, blue, brown, gray, etc., it doesn't matter what order we list them in. They're just names. Car, make. They're just names. Honda, Chevrolet, etc. So those are nominal, and we don't use these typically. We can, but that's not typically what we do for correlations. Instead, we use continuous variables, and let me draw a line here because I didn't leave space. So continuous. And so anything that enters on the scale. So it can be, of course, easy things like height, weight, age, just numbers and sequence. It could be like scores on a measure. It could be like time spent on something. And so let's generate for our use a little bit later, a list of some continuous variables. And I'm going to start the list with an example. So a list of continuous variables. And I'm going to say happiness scores. We've measured happiness. And I'm going to say minutes of screen time. And I'm going to say MPG, miles per gallon, on a car. Now I'd like each of you to come up with at least one continuous variable, and everyone I'm going to bother you about this. So, because we need to have a good list of these variables for a question I'm going to ask you in a little while. So pop into the chat or speak. Let's get a list of some continuous variables.
Would time be something?
Sure, but let's be more specific. Time, what do you want to measure? Like the time doing what?
Reading, maybe? I don't know.
What did you say? Time what?
Reading?
All right, time reading per day. Very good.
Yeah.
Does it include screen time? Well, we won't. We'll ask you that later if we need to. Okay, time reading per day. Sean, let's see a continuous variable from you. Oh, Sean, I see. How many miles walked each day? And I wonder, yeah, all right. Oh, I see a couple here. Miles walked per day. And I see the height of your child each week. Okay. Child's height. I see that you're offering us something a little more complex, Celestin. You're offering us two variables, like the height of your child and like, let's say age by week. So let's just put that, age by week. Safra. Okay, hours of, we all work even when we're not at our jobs. So should we say employment, Rufina? Working at job, okay. Hours working at job each day. Safra?
Yeah.
Just a continuous variable. I didn't see it on the list. All right, pages read in a book. Very good. All right, so these are the kinds of variables that we can use for correlations, and we're going to revisit this list in a little while. So let's continue on to look at how we depict correlations. This will be review for you, Sean, but I think review can be a good thing. So we depict correlations in a scatter plot. There's just one L there, scatter plot. And so a scatter plot has two axes. It has it doesn't go in both directions, so we'll just go in the positive directions. It has the x-axis. And on the vertical dimension, the y-axis. And we place our variables on either axis. This is a y. Let me make sure that's clear. And we place our variables on them. So let's use the example for our scatter plot of quiz scores to exam scores. And let's just, I'm going to put verses there. That's not really what we have. So the x-axis would be our quiz scores. I would say this should go on the x-axis because the quizzes came before the exam. So your x-axis is going to be like your predictor. Whatever is predicting. So it might be the one that came first time-wise, or it might be the one that you hypothesize predicts the other variable. But that's usually what goes on the x, and the y-axis has whatever is the effect or the outcome. And in this case, it would be the exam score. When we're creating a scatter plot, you want to do a little better than I did at making the scatter plot square. The best kind of scatter plot is square, meaning the y-axis is the same in length as the x-axis. Mine is a little short. You'll be drawing these, so it's good to know some of these guidelines. So mine's a little short. And then the scales are going to be evenly spaced. So let's say the lowest quiz score was a 50, average quiz score was a 50, and the highest was 100. And in that case, we would put our values right along that continuum. And let me just do a little erasure here so that I can have room to mark the scale. So x-axis, quiz scores, and the y-axis we have room. So we would just divide this evenly. So let's say 50, 60, 70, 80, 90. It's not quite even, but we could do better than that. Let's say we had the same range. Let's say the lowest on the exam was a 60. Ooh, that would be nice. And the highest was 100. And so then we would have the 80, the 90, and the 70. So you just kind of mark equal intervals along there. And then you get your data. Let's just see, equal intervals, minimum to maximum. And then you get your data in pairs. And I did not go in and get your data yet, but let's imagine that person 1 had an average quiz score. I'll just put these in parentheses. I'll put the quiz score first because it's on the x-axis. I'll write that out for now. X equals, let's say the average was 74 and y equals 68. Let's say person 2. I'm just going to write the scores this time without the x and y, but the first one will always be the x. Let's say 88 for the quizzes and 90. Person 3. Their quiz score was 50 and their exam score was 60. Person 4, 95 and 90. And we would continue on like that. And then we would take each of these and plot them. So you're probably familiar with this, but let's go through and do it. Person 4 had a 74 on this scale, so right about here, and a 68 right about here. So let's go ahead and plot their score. This one's done. Person 2 had an 88, so right about here, and a 90, so right about here. And so where those points meet, we plot. This is person 2. Person 1. We continue on to plot person 3 with the 50 and the 60. Right down here where the 50 and 60 meet. Person 4, 95, right here, and 90. So they're going to be right about here. Person 4. And we continue on plotting these points. So let's imagine that we had a larger class and the points come out something like this. Plotted all of them, and they maybe come out in a pattern that looks something like this. And so this is our scatter plot. And from this scatter plot, we can gain some information. So the first thing that we would want to do is draw a line that seems to come nearest to the greatest number of points. So this line, I'm just going to draw it, eyeball it. It looks like it would be a straight line. I think this line might be close to where a line would be that comes closest to the greatest number of points. And we will call this the line of best fit. And now we can use this line to find some information. The first piece of information that we can find is whether the line goes in an upward or a downward direction. So in this case, we can see that the line of best fit goes in an upward direction, and that means the relationship between these two variables is positive. Positive just means that as one variable increases, the other tends to increase. We can draw one variable increase, the other variable increases. And likewise, as one variable decreases, the other variable decreases. They're going in the same direction. Positive is not related in any way to good. All it means is that the relationship, the two variables vary together. And we typically indicate this with either a plus sign or no sign at all when we get to working with numbers on the correlation coefficients. So what we're looking at is the arrow going upward or downward. And if it's going upward, we call it positive. That doesn't mean anything about good or bad. It just means the two variables change together. So that's the first thing that we can learn about relationships based on the line of best fit. And the second thing that we can learn is about the strength of the relationship. And so we learned here about the direction. And in this case, it was positive because the arrow went upward. And we can also learn about the strength, which I will write over here. And the strength is basically referred to as the distance, essentially the distance of each point from this line. So if we could imagine measuring each of these distances, how far is each point from the line, that would give us an indication of the strength of the relationship. So let's write that down. The strength, the distance of each point from line of best fit. And so we can say the closer the points are, Closer equals stronger. Farther equals weaker. And so this is a basic overview of the scatter plot and a real fundamental look at what we can learn from the scatter plot. So what questions do we have so far? I don't know if you've had this stuff before. Shannon, how's that seeming to you so far?
I understand the y and the x-axis and the scatter plot. I think for me, I would just have to do more to understand the line of best fit.
Good.
So
Yeah, very good. So the fundamentals we're starting to open up the fundamentals here. And to you, okay, so far so good. It seems like. Anything else? Okay, let's go on. So let's dive into this a little more deeply. So in a correlation, we can have a few different shapes. In the scatter plot. So we could have a scatter plot that looks like the one we had. With the points moving in an upward direction. And we'd have a cluster that looks maybe something like this. And our line of best fit would tend to cross the middle of these points and go straight. Or we could have one with points that look something like this. And the line of best fit would tend to go in a downward direction. If we are to give these a name, we would say this one has a positive relationship. This one has a negative relationship. And the only difference is the direction of the arrow. If the arrow goes up, it's positive. If the arrow goes down, it's negative. We could have something that looks like this. With the line of best fit crossing right through the center of every single point. I didn't quite draw that arrow that well. And this one would be called a perfect positive. Perfect because every point is right on the line. Or we could have something like this. And if you can imagine that also being perfectly straight, we would call it a perfect negative. And both of these have in common that every point is on the line. And all of these would have the shape that's considered to be linear. Which just means that the line of best fit is straight. But we could also have some other kinds of shapes. We can have some crazy shapes too. So we could have something that looks like this. Let me move this just a little more. And the line of best fit would have to be curved. And we would call this a curvilinear relationship. It means that the line is curved. It might also look like this. And once again, the line is curved. So also curvilinear. And what we're going to be working in this chapter, we won't be working with curvilinear relationships, but I want to give you an example of what relationships like this might be. And so imagine, let me pull my notes up here. Imagine that you have, this one is from your book, but I kind of liked it. The extent to which your partner idealizes you, like how much do they put you on a pedestal and think you're close to perfect? You know, do they think you're really imperfect and they think kind of badly of you? Or do they think you're like the best thing that was ever created on this earth and you can do no wrong? Or are they somewhere in the middle? And so let me ask you, if we were to compare variable one, let's call it our X variable. I'm going to zoom in a little bit here. Whoops, zoom in here. So let's imagine that we had an X variable, which was partner idealization of I'll just put you, because we're looking at the extent to which one's partner idealizes them. Okay, so now imagine that. And now here's you. And how much does your partner idealize you? And then let's put as the Y variable relationship satisfaction. So now let's say your partner thinks you're the worst thing ever. How happy are you going to be in your relationship? If they think really badly of you, let's get these on a continuum here. Low levels on the X variable. Here is our partner idealization. Let's just make it a scale of 1 to 10. Let's imagine, and let's put your relationship satisfaction also on a scale of 1 to 10. And let's imagine some data in here. So your partner thinks you're the worst thing ever. How happy are you going to be in your relationship? Put up a number here, you guys, okay? Partner idealization is like 1 or 2. How happy are you going to be? Throw a number in, 1 to 10. Let's see some answers just to keep everyone awake. 2, 1, 0. Yeah. Okay. So we think that this is going to be down here. Okay. Your partner respects you, thinks you're a good person, they're aware of your faults, they're kind of in the middle. Partner idealization's around 5. How satisfied do you think you're going to be in your relationship? Let's see some numbers. You're in the middle. Partner idealization at 5. 7. Let me see a couple more of you. 6. 1 or 2 more. 7. Okay. I wish I would see more. So we saw some answers down here when the partner thinks badly of you. We see answers up kind of in this range when your partner, now, this is the next one. Your partner thinks you are 100% perfect. You can do no wrong. You are on the highest pedestal ever. They admire you at every single moment, even when you first wake up in the morning and things aren't good, and even when you're in a bad mood, and no matter what you do, they idealize you. Okay, let's see some numbers. Okay, what you guys are producing is contrary to what the research finds. What I'm hearing is this: a linear relationship. What the data, this is in your book, and I have seen this stuff before, what the data actually suggests is something like this: that too much idealization is a bad thing. This actually has a curvilinear relationship that's something like this. And it's well, I mean, what do you think would happen? Like, your partner thinks you can do no wrong. What happens when you screw up? You know, like, generally people want to be known and loved. People don't want to be loved for something they're not, because inside you, if your partner thinks you're perfect, but you know you're not, isn't that going to make you a little bit anxious? Like, what happens then when all of a sudden it's like children think that of their parents, right? When they're really young, children think their parents are perfect. But what happens during adolescence? I mean, does anyone talk about when, like, during adolescence? Colin, do you have any thoughts on that? Like, maybe when you're really young, you think that your parents are perfect, but what happens during, like, your teenage years when you're 14 or something?
Yeah, I guess you just start to notice that they're just going through life just the same as you.
Right. Yes. And so they fall off the pedestal. Your relationship changes. It's not necessarily bad because you're seeing them more realistically, you know, but it's sort of like that phenomenon of, it's better not to be on the pedestal, because when you fall off the pedestal, it's a long, hard fall, you know, and it can destroy. So that's an example of a curvilinear relationship. I'll give you one more example. This is the example that I use. It's actually the same way, but the inverse U. But I'm going to use level of arousal. And by this, we mean like nervous arousal, like coffee. You drink too much coffee or something, you're really highly aroused. And performance. Let's say performance on any kind of performance, almost. So your arousal just means, this 0 would be like, you know, you're sleeping. You know, 1, you just woke up. 10, you have just drunk like 7 cups of coffee, and you had one of those, what are those highly caffeinated drinks? I can't think of what they are. So you are so keyed up, you can't hardly catch your breath. You're really, really keyed up, jittery almost. And then you're in the middle here is, you know, your mid-range. What happens to performance as arousal increases? So 0, you blew it. 10, you aced it, you know, and then somewhere in the middle. Well, if you're half asleep, your performance is low. You just don't have enough energy going to do well. Once your arousal is about mid-range, you tend to do your best. You're not too keyed up, but you're also not asleep, something like that. And if you get to this really high level, your performance tends to decline. You're jittery, you're answering too fast, you're not doing your best work. This relationship tends to be curvilinear. So that is about all we're going to do with curvilinear relationships in here. We are not focusing on these in our work, although we will take a look at how we would do calculations for these, but we won't be working with it. Questions about the shapes of distributions. We looked at positive, we looked at negative, we looked at perfect, and we looked at curvilinear. Any questions related to these? Thanks, Shannon. Hi, Rafina. Any questions, Alexandra? Okay. So let's get into
No questions.
Okay, thank you for responding, Alexandra. I appreciate that. Let's move on and talk a little bit about how we measure these relationships. So I've already talked to you about how we measure direction. And direction, remember, we're focusing now on linear, not curvilinear. And so I think for now, maybe I'm just going to, so as not to have confusion, I'm just going to cross these off so that we keep our attention up on these linear relationships. And so we look at the distance of each point to the line to determine the strength. And this is the really important thing we'll be working with here is the strength of these relationships. So the direction is indicated by a positive or a negative sign. And so let's just give an example of a negative correlation before we continue. We gave an example of a positive. I'm going to give, before we look at the measures, let me just give a couple more examples of positive and negative, and then have you predict some of these relationships quickly. So positive, we already did quiz grades. Quiz scores to test scores. We could also say, this is another one in your book. They have some good examples, but there are many, many we can generate, which we will in a moment. Another one with relationship satisfaction. The number of exciting things you do with your partner, you do together. That's the X variable. And Y is relationship satisfaction. As the exciting things you do together increases, relationship satisfaction increases. So they vary together. As they decrease together. Negative, and let me caution you, negative is not bad. It just means that as one increases, the other decreases. There's no valence to it. And a couple of examples, we could say boredom and relationship satisfaction. So if you're really bored, you're likely to be less satisfied. We could say, as boredom increases, relationship satisfaction decreases, which is too bad. I mean, I don't know, life gets boring sometimes. And another one is absenteeism from work and job satisfaction. And so let's put this into words. As absenteeism numbers increases. Job satisfaction decreases. And so those are some simple examples. And I'll just give you an example or two of these perfect relationships. So what we could have on the X variable is, for a positive, is we could have height in inches and height in centimeters. And what this means is, if I know your height in inches, I can know exactly what your height in centimeters is. So perfect, I can predict Y perfectly from X. They're all going to be on the line. As an example of a perfect negative relationship, let's put down weeks in the semester we've completed and weeks remaining. So if there are 16 weeks in the semester and we've completed 11 weeks, how many are remaining? We can know exactly that 5 weeks remain. If 16 weeks total and we've completed 2 weeks, 2 weeks complete, we know perfectly that 14 weeks remain. Okay. A little bit about strength and then we'll play a little game, but do we have questions about the perfect relationships? Lyle, you missed it. We're talking about perfect relationships. Just what everyone wants.
Right? I wish I had one.
Yeah, isn't that true? I don't know. I think perfect relationship might be a little off-putting if we actually had it.
Yeah, I just now got out of my meeting, so I hurried and ran to the Windrock Center.
That's fine, but you're going to want to go back and watch what we did already in order to have a sense of what's going on. It's all on the whiteboard this time. Okay.
Okay. Well,
So you'll go back
I'll
and
still
catch
sit
it
in
later.
from here.
Yep, that's fine.
Okay.
Okay, so we were about to talk about strength. Were there any more questions about perfect relationships? Okay, very good. So let's just talk about how we measure strength. We're getting at the conceptual piece today. We're going to do the mathematics of it in our next class. So we talked about the direction of the relationship being indicated by the direction of the line of best fit. So I'll just write that again here. Let me get a different pen color out. And I think I'll just go over to a little bit of a new space here. So let's see how I want to orient it. Okay, I think actually what I'm going to do is erase this and then I can use this one that I've already driven. So this information was showing you how to draw the scatter plot. And what are the things to be aware of? And then we kind of did some illustrating on it. So let's start talking about direction right here. I mean, about the way that we measure relationships. So measuring correlations. We get 2 measures. We've already talked about them both briefly. Now let's go into them more in detail. Direction is the first thing we can measure. And it will be positive. And I think now, since we've talked about it quite a lot, we can simply say, I can simply draw this. As one increases, the other increases. As one decreases, the other decreases. They vary in the same direction. And the line on the scatter plot is upward. And we would have no sign with it, meaning we wouldn't really see the plus sign, but it would be an implied plus sign. We could have a negative relationship, meaning that as one variable increases, the other decreases. So they still vary systematically, but in opposite directions. And the line of best fit is downward. And when we write out the calculation for it, it will be a negative sign. Now, the value that we're going to use to measure correlation is called, I'm going to put it in red right up here. It's called the Pearson R value. And the R value is what we mean when we say there will be a negative sign in a negative relationship. We abbreviate it with R equals, lowercase r equals, and it will be any number between 0 and 1 with a positive or negative sign, or with no sign or a negative sign. So the number part of it, so the sign plus or minus indicates the direction, but the strength is indicated by a number. And the number will be anywhere between, it's a finite number, so I'm going to put ends on this, anywhere between 0 and 1. 1 would represent those perfect relationships that we looked at before. 0 would represent something like a 0 correlation. 0.5 is considered moderate. Approximately 0.5. Approximately 0.8 in the social sciences is considered strong, and approximately 0.2 is considered weak. So let's draw some pictures and plug some numbers to them, and then we'll play a little game. So if we have something that looks like this, I hope you can see these points well enough. Scattering of points that's pretty tight like this, with a line of best fit going in an upward direction, we would give this a likely R value of R equals, I'd say this is probably strong. I'd say this is 0.8, and we would consider it strong. Notice I did not put a plus sign, but it's implied that this is positive, the line going in an upward direction. So if there's no sign, that means positive. If we have something that looks like this, this might be, here's our line. We can see that it's positive. I didn't draw the line quite well. R equals, I won't put a sign because it's positive. This might be in the 0.5 area, and we would consider this a moderate. This is a low moderate, probably the way I drew it. And a weak relationship might have the points even more scattered. Let me move it over a little. Outlier here and there, maybe something like that. But we still do see a line. And so we might consider this to be something like a 0.2, and we would call it weak. And these are just kind of ballpark pictures. If we had something like this, with a line going, we would call this a negative relationship. So we're going to have R equals negative. This is probably 0.8. And so this is a strong negative relationship. If we have something like this, points are a little bit further from that line of best fit, you can see, but still a pretty distinct pattern. This would probably be R equals negative because the line going downward, and probably around a 0.5, a moderate negative. And something with a little broader, little less clean relationship, but still we can sort of see a line. This would be R equals negative, probably around a 0.2, and we would call it a weak negative. A zero correlation, where there's really no relationship, like if I asked each of you to say how many pairs of shoes you owned and what miles per gallon your car got. Those two variables probably have nothing to do with one another. And so we would probably get data like that just was all over the place, points all over, kind of. We could barely even figure out what direction the line is going. And so we would have an R value that is close to 0. So I'll put the approximately sign, 0. It would probably be something like, 0.06, 0.103, something like that. Or maybe negative 0.03, but it's going to be a really tiny number. And we call that a zero correlation. There's no relationship between these two variables. And of course, we already saw our perfect relationships. So here's our perfect positive, every point right on the line. That would have R equals, I don't need a positive sign. So we'll say R equals 1, perfect, positive. And we could have this perfect negative. R equals -1. Which is stronger? This one, A, or B, this one, which is a stronger relationship? R equals -1 or R equals 1? Tell me what you think.
R equals 1B.
Most of you were tricked, but not all of you. Okay, so this is what you have to keep in mind. They're equal. They're equal in strength. So the number equals strength. And so just look at the number, the digit, 1 equals 1. The sign equals direction, but it doesn't have anything to do with strength. And so we could have a plus or a minus, you know, and it doesn't matter. It's equally strong. So the sign in this case doesn't have anything to do with strength, okay? Only the number. So we'll deal with that concept a little bit. All right, we're going to play a little game here. And at first we're going to be really bad at it, and then we're going to get better at it. So let's see how we do. It's sort of fun, I think. Pulling it up. We're coming. The Rossman Chance applet. One of my favorite little correlation games. So what we have in this game is we're going to guess, we're going to indicate how many points we want. Now, a couple of the guidelines for correlation is you usually want to have at least 30 in your sample size to get a good number. Let's go with 50. That's because the assumption of it is that most, you have to have a normal distribution, and this assures a normal distribution. So what we're going to do is we're going to hit new sample. It's going to give us a scatter plot. We're going to look at it and we're going to guess the correlation. And I'm going to click this button down here, track performance, and that's going to show us how we do across time. So let's generate a sample. All right. First question, do we have a positive or a negative relationship? Celestin. This one you have to participate in, everyone.
Positive.
Positive? How do you know you're correct? How do you know?
Because it's going upwards.
It's going in an upward direction. If we drew a line, that's what we'd see. Now, how strong is this? A number between 0 and 1. 1 is perfect. 0 is nothing at all. So what would we say? Kind of in the strong area, more toward the 1, or in the weak area, more toward the 0. Give me a number. It'll be a point something. Correlation number is always going to be point something. Everyone put a number in the chat. Point something for how strong you think it is. We're going to be bad at this at first. Okay. Let's see. 0.6, 0.8, 0.2, 0.5. Okay. So we're kind of all over the place right now. And so and that's okay, because we're going to get better at it as we go. But let's keep these in mind. So strong. This is how I was indicating strong. See how tight the points are? Mine isn't perfect by any means, you know, so just keep this in mind when you're thinking about these. And so let's go with, I think I'm going to go with the ones I see most in the 0.7, 0.8 range. So let's go with the, let's say 0.75 right in the middle, 0.75. And let's see how we did. And the actual correlation here is 0.862. So that gives you an idea now of what these look like. So this one was pretty strong. We can see down here, this is the one that I usually pay attention to. So we were a little bit off, a little bit low. All right, let's get a new sample. Oh, is that ugly? So what do you think? Is this positive or negative? We're all going to be just guessing on this one, I think. Shannon, what would you say on this? I don't even know what I would say.
Would it be like the 0? Because they're
It's
all
going to be
scattered.
close to 0. Yeah, I see Sean put in there Sean put in there positive. Does anyone want to, we have to put a number in, we can't put just 0. So if you think it's positive, you'd have a positive number. If you think it's 0.06, let's try it. So 0.9 would be a very strong relationship. Don't forget to put a 0 there if you're thinking that it's a weak relationship. It's got to be closer to 0. Yeah, 0.0, 0.06, 0.09, 0.08, you guys knocked it out. Very, very good. That's going to be great for our record. Let's try another sample. Oh, what do we think here? So positive or negative, and how strong is it? So I'd like to see everyone put a number in there. I'm looking at my chat. It's here, Safra, Rufina, Alexandra, everyone plug in a number. And I'll take kind of the general of what I'm seeing. Don't worry if you're off on these. This is good practice. Good, good, Rufina, thanks. Lyle, Shannon, excellent. Good, good, good. I'm seeing lots of these in the 0.8, 0.9 range. Everyone's right in that range. I think you guys are right in that 0.89 range. Let's put 0.85. 0.886. We're doing great. Let's look at our record. Yeah, look at how close we are. Looking on this third one. All right, we're going to do up to 10 of these, okay? Here we go. Let's see you plug in some numbers. First determine positive or negative, and then determine strength. Okay, now remember, remember about that 0 sign. So if you think it's really weak, then you'll put a 0 in 0.0 something or 0.1 something. But if you think it's strong, don't put that 0 in. It's just going to be like. Okay. Now we're getting a little confused with the zeros here, I think. Let me just ask a different question. Just put in whether you think this is like a weak negative or a strong negative or a moderate negative. Just put that in for now. Let me just see how that's understood. Weak, moderate, strong. Okay. All right. So you guys are getting that. I would agree that this is, you know, strongish, you know, I'd say it's probably strong. So let's just don't get confused on these numbers. Let me put the whiteboard up again. So think about, it's too bad that we're working with these decimals here, but let's just give it a little bit of thought. So let's draw a big continuum. So here is our 0. Here is our 1. And so maybe in your mind's eye, you can transform these and think about them as 100. So pretend there's no decimal. So let's imagine that this is 100, even though it's not. You're going to add the decimal point after. So if you imagine that this is 100, then right in the middle here, we have 50. And so then way down here, we would have 10. And in between 0 and 10, we'd have, you know, 0, 1, 0, 2, 0, 3. We'd have 1, 2, 3, right? So think about it that way, but then we'll just add that decimal point in front, 0.01, 0.02, 0.03. So some of you are getting confused, like you all knew that this was a moderate to strong relationship. And so if it's moderate to strong, the number that comes right after the decimal point is what needs to indicate that. So here's our 0.8. If I put 0.08, then I'm way down here, 0.08, very, very weak, 0 relationship. So if you think it's in the strong range, you're always going to have that number right after the decimal point. So now that we've thought about that, most of you thought this was moderate to strong, so you thought it's going to be in this range. So give me new numbers, please. That represents moderate to strong. Don't give me zeros in there if you think it's moderate to strong. So let me see new numbers, even if you're not changing yours. Some of you had good numbers before. New numbers. Good, better. Let me see more. Celestine. Okay. Yes, good. You remember the negative in here. Very good. So remembering the negative and then remembering not to put the zeros in. So let's put the negative. I'm seeing most of you in the 0.7, 0.8 range. So let me put 0.75. And it's actually minus 0.8, but we're doing great, you guys. So let's do some more. All right, here we go. First, think about if it's positive or negative, and then if it's going to be like in the strong range, moderate range, weak range. How close are the points to this imaginary line? And give me numbers this time. Give me numbers. So 0.5 is moderate. Okay, good. Let me see some more. Good, good, good. One more. Or did I get everyone already? I might have gotten all of you. All right, good. So I'm seeing ranges in the 0.7, 0.8 range again. So I think this is going to be higher. I'm going to override and say this is going to be 0.87. If I'm wrong, I apologize, you guys. 0.942. Okay, if some researcher got this, they would be delighted. So look at this now and think, okay, that's what a 0.9 looks like. All right, let's do another one. Here we go. Now we're probably looking at something in that moderate range, I would guess. Let's see some numbers. Don't forget the sign, don't forget the direction, positive or negative. And then let me just ask someone for a number. So let me just ask Celestin, what number do you think this would be? I think I'm going to just put what you think.
Negative 0.4.
All right, let's see how this goes. Okay, it's negative and it's 0.595. So now look at this. This is kind of what a 0.595 looks like. Okay. And let's do two more because we're running a little low on time here. We'll do one more. All right, this is it. Let me have everyone put your numbers in the chat. Positive or negative. Looks to me somewhere between moderate and strong. Yeah. Seen a range of numbers between 0.5 and 0.75, I think was the highest I saw. So let's go somewhere in the middle there. Let's go with 0.65 maybe. And look at that, 0.656. Let's look at our record. All right, so this is our record. So you're actually going to be doing a little assignment with this. You're going to be doing 10 little trials and keeping track of it and seeing how you can do independently. And so you'll be then taking a screenshot of this page, in particular this, and look at our correlation. We had a 0.996 between our guesses and the actual. So we did really well, a really strong relationship between our guesses and then what we actually had. So very good. Questions about this? Anyone? Shannon? Anyone? Okay, we have two more concepts to go through today. And so let me get the whiteboard back up for us. And remember, in our next class, we're going to actually do the calculations. So this class is for the concepts. And so what we're going to move to next is interpreting correlations, which is one of the biggest challenges. So you'll recall that we are using correlations to show relationships, but not causation. And let's look at why. So imagine that we have a correlation. We have a relationship between Facebook use. So variable 1, we're going to put for the X variable. Facebook use, and we'll just say number of minutes per day. And our Y variable is depression,
Dr. Russ, what does that say? Relationship, comma, not what?
not
Or-
causation.
Oh, not causation. Okay.
Yeah. So these are the two variables we're going to work with. This is actual data from a study. And it suggests that there's a relationship between Facebook use and depression in teenage girls. And it suggests that the relationship is positive. Not, that doesn't mean good, remember. It means that as Facebook use increases, depression increases. So they vary together. So my question is this. Question. Does this mean definitively that Facebook causes depression? And in this case, so in this case, the answer is no, we cannot conclusively determine that Facebook, sorry, spelled that wrong, causes depression. Why? Because there are 3 possible explanations for the relationship. The first explanation is that we're right. Maybe. We expected this. Our expected relationship was that Facebook caused depression. We expected that X, Facebook, caused, that arrow means causes, Y, depression. And we always ask this question, let me change my color here. The question we ask each time we identify these relationships is this plausible? Is it plausible? Is it believable that it's possible that Facebook causes depression? If so, how could that be? So I'd like to hear someone, so let me just ask someone, Shannon, is it possible that in teenage girls, Facebook causes depression? That could Facebook cause teenage girls to feel depressed? If so, why? Like, why would it make sense? I know.
Did you call me, Dr. Ross?
Could you repeat that, please?
You asked if Facebook causes depression, right?
No, I didn't ask that because we can't know that. But all I'm asking is it plausible? Does that seem like a reasonable? Does it make sense? Could you think of a reason why Facebook could cause depression? Could you?
Yes.
Okay, why would that be? How could that be?
They compare
Okay, yes,
what is on Facebook.
let's put that. I like it. Yes, because they compare. Oh, in a new color here. I would say, yes, perhaps they compare themselves unfavorably with others. And that could cause them to become depressed. Leading to depression. Okay, let's look at a second possible explanation. It could be that that's not true, but in fact, the reverse is true. So the second explanation is what we call the reverse cause effect. And in parentheses, I'm going to put Y causes X. In this case, that would mean Y, depression, causes X, increases in Facebook use. And so we ask this question once again. We ask, is this plausible? If so, why? So think now, is it plausible to you that somehow having higher levels of depression would cause higher levels of Facebook use? And I saw a yes here from Sean. Sean, how could it be that, how do you explain that in your mind, or how do you make it make sense to you?
Well, the person could already be, there could be other factors like outliers of reason why they're already depressed. So being depressed, they find an outlet, which would be being on Facebook to kind of like a coping mechanism. Then there could be other outliers, or why should they're already depressed by, let's say, blue screen computer with all the energy that comes off of a computer. It does something to your, I think your, it messes with your mind.
Your
This,
circadian cycle and your,
yeah.
yeah.
So there could be a lot of causes. So that would make the reverse of this one. Other causes, other causes for depression, and because they're already depressed, you could be also going on there just to find an outlet.
Okay, so in the first example we gave, Facebook came first and then came depression, right? In the second example, the depression came first, like what Sean was just explaining. He said they could be depressed because, hormones or, any number of things could have caused them to be depressed, and the depression maybe preceded the Facebook use. When you're depressed, you don't want to do very much. You stay home a lot, you're not feeling motivated. And maybe in that unmotivated staying at home state, you are just using Facebook more because you're just staying home more and sitting on your screen a little more. So it could be that, I'm going to write this out. Yes, this is possible. The depression could have occurred first for other reasons. I'm giving a nice explanation here. And since depression turns people inward. Girls with higher depression might stay home more and thus go on Facebook more, just because they're home. So I'm trying to write these out in really good words. So we have our first possible explanation, which is the expected cause effect. We have our second, which is the reversed cause effect. The third possible explanation is called the third variable. And let's name it as some unknown factor Z causes X and causes Y. And so in this case, we would have to think of some unknown factor that could cause both X and Y. So can we think of, it's plausible if we can think of even one factor that could cause depression and also cause increased Facebook use. So I want each of you, to think of and plop in the chat an example. So everyone who's here. So Lyle, Sean, Shannon, Celestin, Alexandra, Rufina, throw something into the chat. A factor that might cause both depression and increased in Facebook use. I see one. I'm not going to say what it is until I hear a few more.
What is the question again, Dr. Ross?
Yes.
What is the question again?
Any factor, good, Celestin. It's written up here. Can we think of a factor that could cause depression and also increased Facebook use in teenage girls? Interesting answers here. Low self-esteem. Okay, I'm seeing some good answers. Loneliness, expectation. I would want to hear more about that. I think, Rufina, it sounds interesting. A death in the family, low self-esteem, poor parental monitoring, maybe. And I would say that each of these are good answers. So in this case, we would say yes. Let's take, bullying, rumors and stuff like that. Let's just take that one since it's right there. Bullying, rumors, all that kind of nasty relationship aggression that can happen. That could cause people, it could cause depression. And it could cause girls to go on Facebook a lot. They're monitoring things, right? I think that one makes sense. We could plug in here the low self-esteem. They feel bad about themselves, so they're feeling depressed and they're going on Facebook a lot because this is a point of anxiety for teenage girls. Or loneliness. Yeah, they're lonely, so they are feeling depressed and they're seeking out to satisfy that loneliness by going on Facebook. Or maybe like parental neglect. You know, that could cause girls to feel kind of depressed and lonely. And since the parents aren't paying attention to their social media use, it could also contribute to going on Facebook a lot. So if we conclude, when we look at a correlation, that A causes B, we have to use a great deal of caution because we can see here that there are 3 possible explanations for a correlation. And so we have to be really careful. But what often happens is that newspaper headlines don't pay attention to that. if they see a correlation, they often plug right in and say, well, then we know A causes B. And so this is the caution that I have to advise you of. And I'll show you a couple of headlines and we'll take a look at one more of them. And I'm always looking for such headlines. And so I'm just going to show you some headlines that I've taken. Oh, all right. Actually, I can't get that open right now, so I'm just going to leave it alone. I'll show those to you in the next class. So these three explanations are really important, and the work that you do in this chapter, you're going to have to work with these a little bit. We're going to do one more super quick one right now. There was a newspaper headline that implied that based on a correlational relationship that the X variable, health, the Y variable is happiness. And let me be more clear here. I should have written heart health. Heart health and happiness. And as it was a positive relationship, and it was among older adults. Okay. And the newspaper concluded that something like this. Want a healthy heart? Be happy. In other words, they concluded that happiness caused heart health. I should have reversed these two. In fact, I'm going to reverse them now because it'll make it easier to discuss. X was happiness, Y was heart health, and they concluded the expected direction. Happiness causes heart health. And I guess we could say that's plausible. You know, maybe happiness causes some sort of hormone, oxytocin, or something, and it makes you easier and less stressed. So if you're happier, your heart is healthier. Maybe that's plausible. But is it possible that the reverse is true? Y cause X. Could heart health cause people to be happier? What do you think? Could heart health cause happiness? What do you think? Someone who's here yet? We're almost done.
I think so.
Yeah, how so?
Because in order to have a healthy heart, you would have to do some type of exercise regimen. And usually after you do something, you do any type of exercise, your body automatically, you know, it absorbs it, and you feel good about doing something like that for yourself.
Excellent. And you just gave us a very fine example of third variable. You proposed that exercise causes a healthy heart, which is, I think, accurate, and also causes happiness.
Yes.
So this is a nice third variable explanation. And just for the sake of time, I would say the reverse is also true. Like maybe if you're older, you're looking at your friends and a lot of your friends are having heart trouble and you feel really bad for them, but you feel really grateful that you have a happy heart. And that gratitude that you have over having a healthy heart causes you to feel happy. Maybe something like that. Do you see what I mean? The little bit of a difference there, how we introduce a third variable when we add exercise because we're saying it causes both. But here I'm just explaining how heart health itself could cause happiness irrespective of a third variable. Okay. So this is what I have for you today. We didn't get to talking about outliers and range restriction, but we will in our next class. So let me stop the share, ask if there are any questions, and you would be able, with what we've learned today, you'd be able to go in and do the 4 practice quizzes that are available to you, but there will be a couple more that I'll be posting. I just want to double check them. But any questions? Or anything?
Russ,
Yes,
It's Dr. Ross.
2
we did-
questions. First,
we did-
Lyle?
we're on chapter 9, right?
Nope, chapter 11.
Okay, all right. I just want to make sure. I'm
Yeah,
in the right-
we're not going to take those this term.
Okay.
Shannon?
All right, thank you.
I was just going to ask about the scatter plot that we did.
Yes.
So I'm not sure if that's like part of the assignment, but would we have to guess at the number like we were doing, like the 0.2, 0.5?
No, we'll be calculating the numbers, but doing this exercise helps you to understand what the scatter plots would look like with a certain number. So it gives you the capacity to, when you make a scatter plot, to look at it and say, that's looking like a weak relationship to me, or that could be a strong relationship. It just helps you know if your numbers are accurate.
Okay, yeah, because I was wondering about that, and I was gonna ask like how you're gonna grade if we had an assignment that came across like that.
No, this is just for your benefit. Yeah, but we'll be calculating. So that's what I won't be grading you on any of your guesses. You know, I'll just be giving you some practice in that.
Okay.
Anything else? Okay. Then I will say goodbye. All of you go out and vote, and thank you for all that you're doing to help to make sure you vote and help other people vote. And I'll see you on Thursday. Agone. Agone.
Awesome. You all have a good day.
Bye.
Bye-bye.
Bye.